We are about to create z-scores together. Z-scores are when you talk about like standardized data, if you've ever heard that term, and we'll get some sense as to what that means soon enough. A z-score is a transformation of your data. There are really two transformations in play. The first is a shift in all of your data points, and the second is a scaling of that new data set, or a rescaling, as it were. Let's take a look at what's going on. We have our linear function y equals mx plus b, and what's going to be happening, and we'll show you this with a spreadsheet, but our new value, our new data column, is going to just be the same as our old data column, so just 1 minus the mean of the original data series that we were working with. If we're dealing with a population, then we're going to use the symbol mu because we're working with the population mean. If we're working with a data sample, it's going to be x bar, the sample mean. But the formula is the same either way, and we are shifting our data. Notice we're just doing y equals 1x, so no scaling of our old value, plus b. And in this case, the plus b part is that we're subtracting the mean from all of our data. Let's take a look together. All right, let's see how a linear shift works in practice. First thing what we're going to do is we are going to create a set of random data. Then we're going to stabilize that random data in the spreadsheet. Finally, we are going to calculate the mean and subtract the mean from every data point that we have. So that's a mouthful. Let's take it step by step. First thing is let's just create some random data. I will put in equals rand, and I'm going to scale this by 50. Okay, so now I have a set of uniform data. Every value is just as likely as every other value, and it scales between 0 and 50. I find here that my mean is 26.17, and my standard deviation is 13.8. Now, your data is going to jump around on you a bunch based on any new entry you make. A way around that is just Control-C, Control-Shift-V if you're a PC user, Command-C, Command-Shift-V if you are a Mac user. So I'll put this in, Command-C for me, and then Command-Shift-V, and now all my data is stable. It's not going to jump around with every little new entry that I make. Okay, so our average is 26.17. In this new column that's just the mean column, I don't really need this. It's just to give a nice little demonstration of what's at play. This column here is not strictly necessary, but I'm going to put in equals $B $2. And that is the mean. And then from the mean, I'm going to subtract the mean from my original data point, which is the same as the deviation, right? The deviation of the data from the mean. So the mean was, call it 26. The actual data point was 35. 35 minus 26 is 9.16. And my new data column, as it were, is just the old data minus the mean from the old data set. And it's a little confusing. But what do we find in this new data column? Well, the new mean, the new average of this data column is 0. That's how all standardized data works. When we subtract the mean of our original data set from every value in our data set, then the new data set is going to be centered on 0. And we've actually talked about this when we were exploring how standard deviation works and variance and all that. The last thing to show you, why call it a linear transformation, that whole y equals mx plus b? Our original data set ranged from 0 to 50, and in a very linear, very methodical way, our new data set goes roughly from negative 25 up to positive 25 because, well, it's not that we're subtracting 25 from each and every value that we had before, but we're subtracting 26.17. There's just been a linear shift in all of our data.